Okay, so today is 8.3 and we're doing day 2 of it, even though it's mostly just a review of what we did on Friday. Okay, so if you were going to solve this, I hope you know that you can take the log of both sides. You can just slap a log right here and a log right here. But that's not necessarily the easy way to do these problems. Sometimes there's something really simple, like do you get that both those bases could be made into a base 2? As soon as both of them are base 2, it's easy. That becomes 2 squared to the x. Do you notice how that pretty much becomes 2 to the 2x? Equals 2 to the 3x minus 1. And why is that good? Because if the bases are the same, that has to equal that. And it's just 2x equals 3x minus 1. If the bases can be made the same, that's a very simple way to do it. Now, that only works if we set it up that way on purpose, to let the bases be the same. So what if they aren't, like in number 2? You cannot make a 5 and a 2 do that. So we need a way. Well, I can take the log of both sides. Or I could do log base. If I'm starting here, reading from left to right, what's my base? 5. And then everybody rewrite it from there. Log base 5, you'll have to go to the other side and come back here. That's how a rewrite works. And then you'll still maybe notice that you still have x's in your exponent. But there's a way to fix that, because you don't want the x's in the exponent. Log base 5 of 2 to the power of x plus 7 equals 5x. And why can't I just solve it now? Because I still have x's in my exponent. Got to get those down to where the normal spot is, like on the normal level. It can't be an exponent. So do you get I can just drop those right down in front because of the power rule? If you have an exponent on the argument, it can drop down in front. I'm going to put it in parentheses just so I don't by accident start thinking that only the 7 is being multiplied by the log. Now, this gets really complicated, but you're in honors pre-calc. You're supposed to be able to handle this kind of stuff. I'm going to ask you to distribute this x plus 7 with this log. Remember, this is just like a single number. If I knew what it was, it might be like 1.8. Okay, that's just a single term right there. Distribute it out, then you'll have two things being added equaling 5x. Everybody multiply that out. Let's see if you can get that. Just multiplying. And log base 5 of 2 is a number. Did you say x times log base 5 of 2 and 7 times log base 5 of 2? Do you have that? Okay, good. Now, if I just said solve, that would be very cruel because this would take you a long time because it's got some twists. I'll give you this much setup. You got to get the x's to the same side as each other before you solve it. Okay, so I'm going to subtract 5x from both sides, and I'm going to do a double step. This is dangerous. I also don't need this on the same side with my x's because do you get that's just a number? It's just a number. I don't know what the number is, but it's just a number. There's no variable in there. So I want to get that to the other side. So I'm going to subtract 7 log base 5 of 2 from both sides. Double step. There. Now, isn't that easy? It's not too hard. If you can remember one of my favorite sayings, you'll get it. It may take a minute and just struggle with this. Trying to find x. X will equal some stuff with logs in it. Once you see it, you'll be like, oh, I get it. I've got several favorite math sayings, but I don't have that many. You kind of go through them, and one of them applies. I'll pause and take attendance while you give this one a try. Okay, so if you can factor it, you should. So I factored the x out. Why is that any better? Because now x is down to just one x. You will never solve something unless you get it down to just one x. Now, how do I get that x off of there? It's being multiplied, hint, hint. Divide both sides by this part that needs to go away. Log base 5 of 2 minus 5. Log base 5 of 2 minus 5. And now, x is alone. That was a tough one. You don't actually have to figure out what log base 5 of 2 is and figure this out. If I had a calculator, if I was going to have you do that on a calculator, and you get the answers like 1.6, and then you just multiply it all in. If you were going to use the calculator anyway, then why wouldn't you just graph this and graph that and what? See where they cross. If you haven't learned that yet, that's a very powerful method. If any weird looking equation that you can't solve, if you just graph both sides separately and see where the two lines cross, that will help you on the ACT. I think I figured it out on average about 7 times on each ACT test. You could just simply graph what they've given you and see where the two lines cross. Now that assumes that sometimes you'll have to figure out what equations to write, because the ACT will give it to you in word problems. Like Larry makes $40 an hour plus a $10 bonus. Well, that's actually an equation. And then the other equation they give you, and see where they cross. It's really not, it's a very, very powerful method. Okay, so no calcs, otherwise that's what we would have done in the first place, just graph it. All right, so then your answer's like that. And yes, you could actually simplify that down further, but that's such a nasty one that we're not going to try. All right. I'm going to give you another one that's similar. Solve for x. If you learned anything from what I just showed you, you should be able to solve this one for x. And yes, the answer will have an A in it. Solve for x. Okay. I would agree, except I just have this thing about always wanting the x to be on the left side. It's not wrong. What you said is absolutely right. But I'm going to choose to go the other way and go this over here and that over there. That way my x stuff is all on the left. 5x minus ax is equal to 2 minus 8, which would be negative 6. Did you have the same thing except reverse? Okay, then we're good. Okay. HD in the back left. What do I do next? Yeah, if you can factor it, you should. See, x comes out to the front. Once again, factoring comes through and saves the day. And now I'm finishing it off. Miss HR. How do I finish? And this is x equals all that. It's okay to have an A in your answer? Yeah, you're in pre-calc. You're going to have lots of answers that aren't just 2. You're going to have lots of weird answers. Okay, so that's a review of solving some of the harder ones. That's not a U substitution, though. We need to do one of those. E to the 2x plus 3e to the x is equal to negative 2. First thing I would do is make this into a great big quadratic equation, and those you always want to equal 0. Then I would do a U substitution. Let's see if you remember how to do that I know you guys had kind of a rocky lesson on Friday because you had a sub and had some issues with playing a video, but I'm going to walk you through this if you didn't catch it the first time. So your first step was add 2 to both sides. So this is plus 2 equals 0. And then I hope you get that this e to the x right here is the thing you want to pull out and let u equal e to the x. If you do that, you'll have a nice quadratic. Okay, doing that, you should now have u squared plus 3u plus 2 equals 0. That factors, if you can factor it, you should, u plus 2, u plus 1, checking to make sure I did it right. First, u squared. Outside, 1u. Inside, 2u, make a total of 3u. And the last, 1 times 2 is 2. Yay, it worked. So my answer must be u, well actually u must be negative 2, and u must be negative 1. Now, that's a u substitution, but because we made the problem easier and it got down to u, you should know that if you have a u here, you're not done. That's why in calc they kind of use u as a special variable. It's like a danger variable. Because if you're leaving your answer in terms of u, you are probably forgetting to do the u substitution back again. So I go back and say if u is e to the x, then e to the x equals negative 2. And e to the x equals negative 1. We swap them. And then we're still not done. You cannot stop right here and say, I know some of you are thinking you have an issue here, but you can't here do that. The next level is where you can say, wait a minute, this isn't going to work. So I do a rewrite and I say log base e of negative 2 equals x, and that's where I have broken a rule. There is no rule that says the answer to an exponential problem can't be negative, because you could have a variable that is negative. That's not breaking a rule. But this is breaking a rule. What rule is it breaking? Can't have a negative, what is that spot called? Argument. You can't have a negative argument. Therefore, extraneous. The other one's the same thing. Log base e of negative 1 equals x, and you can't have a negative right there. Extraneous. If the both answers were extraneous, then there was no solution. The problem I gave you in the first place had no solution. And of course, if you just wrote no solution at the beginning, you don't get any credit. Because I know if you get stumped on a question, saying no solution is your best hope. Because maybe there is no solution. Maybe that's why you can't find it. But if you don't have the supporting work as to why there's no solution, you wouldn't get the credit. All right. Could I have made this in such a way that it would have factored where one of these things would have been negative, and therefore I could have had an answer that came out so it worked? You know what I mean? So that this number was positive? Sure. You can make them work, but that would be easy. All right. So that's called a u substitution. You use it when you have complicated quadratics, but you realize that the thing is a quadratic because one of them is squared. One of them is got the same variable repeated, but it's not squared. Then it's probably a quadratic that you could use a u substitution and solve. All right, and then the last topic that I would want to make sure you get here is that this is what it's all about. Can you rewrite this? Right now, it's an exponential. Make it a log for me. Well, obviously, I have to write log. And as soon as you write it, that'll make you think, okay, so what's the base? And if you look at this, you can say, oh, the base has got to be e. If you just sit and stare at your paper, you're like missing a chance to give yourself hints. And then you go, okay, well, okay, if the base is e, oh yeah, then I got to jump to the other side. Hopefully some of these memories will kick in. And then I jump back. There we go. Is it solved for x? Yeah, If the question was solved for x, the answer would be log base e of y. Is that another thing? Is this the exact same thing? Ln ey? Nope. Ln y, though, would be the same exact thing. Yes, sir. Ln? Yes. Some people say natural log. Yes, I would accept ln, natural log, for this answer. But honestly, I think you're safer to put this, only because a lot of times it's something like this, and you don't notice that, oh, if you write the whole thing out like I've suggested, you'll go, oh, this is actually just 5. But could you see how a kid might leave their answer like that on a test, thinking they were done? And it's actually, ln is log base e, and now it's really just 5. Okay, so be careful. I'd always write the bases out. I think it's the safest thing. All right, so that's rewriting. And if I graph them, do you know the difference between the blue one and the red one? One of them's a blank and the other one's a blank. Name them. Write them on your paper. They're the two major kinds of functions we've been studying. All right, did you say exponential for, I should probably use blue up there, exponential for this one? Somebody might give an example, which would be like y equals e to the x, or it could be 2 to the x, or 7 to the x. I don't know what the base is. Raise your hand if you had that one right. Okay, and the other one, which happens to have a very special relationship to it, is the log graph. Otherwise, you could write y equals log base x. No, we know the base. We don't know the argument. Log base, I don't know what the base is, so I'll say maybe let's log base 10 of x. All right. What if I said that these were exactly inverses of each other? Generally speaking, they are inverses. But the way I just wrote them, they are not inverses, because one of them is in a different base than the other. Change this one so that it would be a true inverse of the other one. Mr. O. Or ln x, yes. All right. And do you get, we could have taken this, swapped to x and y, and rewritten it as, oh, log base e of x equals y. Look at that. It's the exact same thing. So if you take your original and you do an inverse right, you can get from the one to the other. So we should be able to go backwards then. So what if you knew that this was log, let's just say log, which means you know what the base is. Then what would the corresponding inverse be? The x is the argument, yes. Okay, so to do this kind of a swap, Mr. DG, tell me what I'm supposed to do to like take this and rewrite it as its inverse. What's that little three-step property? All right, so x equals log base. Should I write the base? Maybe I should. Base what? Base 1? I don't think so. No, it's not base y. If I just had the word log there, what base was implied? There we go. Log base 10 of y. There we go. Doesn't that look a little weird? So now we got to solve it. So how do you solve something like that? Jay, how do you solve that? Hint, sidebar. What did I say about logs and exponentials? The most common question where kids get stumped and they don't know what to do. What are they supposed to do? Yeah, flip them, rewrite them. So, go ahead.
It would be
Center the x equals y. You got it. It's once you get that it's a rewrite, it's really not hard at all. But you get stumped a lot of times. So I'm warning you, when you get stumped on your test that's coming up, not tomorrow or the next day, you're going to have like some problems that are like, oh, I don't know what to do. Remember my advice. If you can factor it, you should. Comes in handy sometimes, even in these. U substitutions can also be a way to take bewildering problems, substitute in one part, like say u is equal to these things. Every time I see e to the x or whatever. And the last thought is, try the rewrite. If you rewrite it, if it's not a log, make it a log. The whole test is about logs. Or if it's an exponential, or if it's not a, or if it is a log and it's in this log form and it doesn't make any sense to you, try rewriting it, make it into an exponential. All right, so that goes up there. That is what y is. Okay, so, oh, last thing. Solve. Two ways you could do it. Give me one way you could do it real quick. Yes? Graph it. True. No calculators allowed. Still two ways to do it. Give me a way. Yes, sir. You're going to log both sides. I like it. But then, I still have x's in the exponents. Mr. Smart Guy. So, know what to do. You can do this. You're only one step away. Yes! That can go down to the front. You remember the rules on logs? Now that it's a log, you can put the x down there. And this can go to the front of that. Now, somebody else is going to do it a different way. And they'd say, but Mr. Server, couldn't we have just taken this original problem here and rewritten it as a log and said log base 2 and then jump over here of 5 to the x plus 2 and jump back equals x. Yes, you could. And then that x plus 2 can go down in front. That would also worked. It's just a rewrite. Like I just said seconds ago, when you get stuck on a tough problem, you can always rewrite. It doesn't have any logs in it now, so make it have logs. Okay, but you can also do the log on both sides thing, which is what we were doing right here. So let's do that. Final answer, x log 2, notice I'm not saying the base, is equal to log 5. No, wait, I gotta put the x plus 2 in front of it. Put it in parentheses. All right, now, remember that deal where we got to get the x's all to one side, etc.? Okay, I'm not going to run you through this whole thing again, but if you distributed this out, you'd have x's on both sides. Then you'd get x's all onto one side. Then you'd be able to factor it. If you can factor it, you should. The x will be alone then. And then you just divide by what's by the x. But don't need to go through the whole rest of that problem. The main point is, do you know how to get it set up so that you don't have x's in the power anymore? Because if the x's are up here in the power, you won't be able to solve it. Unless you graph both sides and see where they cross. But there's no calculators for this next test. All right, so that's a review of pretty much everything you needed. Now let me show you what I want you to do for homework. It's in the parts to consider day 2. I know some of you probably went and watched the movie at the home like you were supposed to, and you know I assigned these 3 yesterday. Okay, and obviously if you haven't already done those, I'm not grading today because we got to spend the rest of the time doing the lab. Okay, but I am going to grade homework tomorrow, so be aware. So those are assigned, and then I also want you to do these 2 at the bottom of the page. This one, number 34, reminds me with that little, as soon as I see one of these symbols I think, oh, that's like the end on a number line. So that reminds me, I need a number line to be able to get this. And I'll do a rewrite and figure out there's some important spot right here that's ln of 53, I think, after I've rewritten it. Let's actually do the rewrite on this. Everybody do number 34 with me right now. So do you get its log base e of 53 equals x? That's the rewrite. Now there's a way to know whether that sign should flip or stay the same. And here's my advice to you. Do you get on this equation the x's are on the left? Let's keep the x on the left side of the equation by just saying x equals instead of equals x. Now, do you get that if I keep my x's on the same side of the equation as they were in the first place, then the sign stays the same? It's just a greater than. There we go. So now if it's a number line, and I don't know exactly what that number is because I haven't happened to memorize ln of 53, some number, but it's here, whatever it is, would that number itself work? No, so I leave it empty. Would things that are bigger than that work? Yes, because it says greater than. There we go. There's my answer. I helped you with 34, probably helped you too much. But you'll have to do number 35, which is similar anyway. And on number 35, you get the clump alone. It's one of my favorite sayings. Do you get that this right here is the clump? So you get that alone first. And then you can do a rewrite. All right, moving on. Next part of your assignment. These are all, use your calculator to help you solve, so they become incredibly easy. You graph both sides and see where they cross. In fact, I think it's too easy, and considering I may have no time for homework for today, we're skipping all of the rest of the ones on this page. But do you get that rule? Complicated equation. Just graph both sides, see where they cross. If this had been a greater than sign, it'd be a little more complicated. Then it would be like where the one function, which looks, this is what 2 to the x looks like, right? And the other function, and that's kind of what that looks like. Where, actually, I think it's not quite that wide. And that one's a little tighter. Hold on just a second. Let me get these more accurate. If I wanted to know where the 2 to the x is bigger than the x squared, the 2 to the x is the red one. Where's the red one bigger than the black one? The way I drew it, the red one's always underneath the black one, and therefore it's never greater than. You'd say no solution. So if it's a greater than sign, all you'd have to do is graph them, see where the one's above the other one. What if I had wanted to know when the x squared is bigger than the other one? I'd say always, except for the one spot where they touch, like right there. And if it had been something like this, where the one was like clearly underneath the other one, like let's say we had a graph that goes like this. Where's the red one above the green one? I'd say, oh, from here on, which would be from 0 to infinity. The red one's above the green one. So greater than means above. All right, enough of that. And I am assigning number 48, part A, B, and C. That gives you a grand total of like 4 questions to do. Granted, one of them has 3 parts. You may also skip number 10 here. And I'm pretty sure there's no more questions there isn't. Good. Okay. So the word problem there will stretch you a little bit. That's good for you. Now we have the M&M lab. I'm going to leave the video going for a few minutes while we talk over the M&M lab, because is there anybody who's gone? Actually, you know what? I'm going to make a separate video for the M&M lab. So I'm done with today's lesson, and that's it for that.